All right, folks, this is a very simple one. It is a paper, this paper, Nougat. The idea is very simple, but its implications are huge. This, I believe, has come out of Facebook. Yeah, Meta AI, recent. I love this because one of the things that many of you, for example, were trying to do is you were trying to get the text out of PDFs in this project, in this bootcamp. And when you did that, you used all sorts of things. For example, you used the very mature text extraction library, Apache Tika, isn't it? Which does a great job of taking text out of normal text out of PDFs. But there is a problem with that. When you talk about scientific papers, scientific knowledge, it comes with equations and tables and things, lots of equations, mathematical stuff. And so, and I know that some of you try to do it with AI papers, but AI papers are littered with equations. And a thing like just plain text extraction does a pretty poor job of it, right? So now, by the way, see this, I have also posted the sample code to our Slack channel. Did I or did I not for Nougat? I think I posted this Jupyter notebook for Nougat and the class for Nougat onto our Slack channel, the sample code. So it is quite effective. Obviously, eat your own dog food mentality. The Nougat library literally takes the first page of this paper and tries to extract text from it. And as it shows, it does an amazing job. It makes it into a nice markup. Right? What this paper is doing is it is saying, hey, since we have reached up to donut, what was donut able to do? It was able to do text detection and text recognition both in the same model. If you remember, last time we did it, that you can do text recognition and detection and recognition in a single pipeline. And it even led to better results. So these people ask a different question. It's an interesting twist. They say, suppose we don't train the machine to recognize text and just emit out plain text, but we ask it to produce also the, let's say, the LaTeX markup in which most of mathematics is written. Can it produce it with the LaTeX markup? The LaTeX markup, right? So the architecture, guys, do you see the donut-like architecture here? This is a simple donut architecture. What was the first part of the donut architecture? It was a swing transformer, isn't it? Right? What was it doing? It is standard encoder-decoder model. If you recall, this is your encoder, this is your decoder, right? And encoder takes an image of a page. Let's say that this paper takes the image of this and creates it into a token, a latent representation Z, except that the decoder treats it as though those are, is basically it treats it as a sequence, right? And therefore, it starts applying an autoregressive, decoders are autoregressive, and it starts applying a decoding methodology to figure out what text it is, with one caveat. The one shift they did is they used the labels to be the actual LaTeX. And so look at this. How those of you who are familiar with tech, would recognize the tech, right? So for example, in this is the way you say there's a section called the title, right? We study the formula. This language, if you're not familiar with, it is the language of LaTeX, right? This is how mathematics is written in formal documents or research papers. You have this decoder decode into LaTeX, and if you can do it to LaTeX, you realize that from there onwards, the rest of the journey is very, very easy. Right? So in reality, what happens, most of us write like this. So for example, the notes that I've given you, I don't know how many of you knew that I write it in LaTeX. Right? We write it in LaTeX because it has mathematical expressions. Then I compile it to PDF. Right? I compile it to a PDF, and therefore that is why one reason my PDFs are not very easy to embed into Word docs and so forth. So this is the journey they talk about. The source file is converted into HTML, which is converted to Markdown, the LaTeX source provided by the author, the HTML file computed, the HTML file computed from the LaTeX source using LaTeX to ML, blah, blah, blah. So what you do is you take the pages, you split it, and a bag of, I mean, the rest of them are technical details, but basically it's Nougat with appropriate customization. And you realize that if you do this, if you recognize, and this is the most impressive thing, it says, example of a page with many mathematical equations. Let's zoom into it. Look at this example, guys. Do you realize that this is as heavy as math can be? Right? It has just about everything. It has the integral symbol. By the way, this is not P but rho. It has Greek in it. There's a gamma in it, which is not T. Hard to recognize, isn't it, normally? Right? And they have lambdas. Lots of kappas are here. This is not K, but kappa. It is littered with Greek symbols. Right? It takes this image, understands it, produces LaTeX, which if you compile to a PDF, becomes the PDF on this side. Right? So this is the think of this on the left as the reality, and on the right to be the interpretation. I'll let you judge how well it has done. Would you agree that it has captured the essence, except for some minor, the lines being slightly different? Because when you compile, smallest, by the time you reach here, cosine inverse, etc., it's on the next line, because the font widths vary, a little bit they vary. So you reach here, and the bounding box has disappeared, but all other things are the same. Right? Are we together, guys? So this is an example of how well it can do. And to me, it's an example of how you build upon research. You know, a donut paper came out, and all of a sudden you ask this question: what if I was training it not to produce plain text, but to produce LaTeX? Would it be able to do that? And sure enough, it was able to do that, just like that, right? With obviously you had to do some cleverness, and those clevernesses are mentioned here, right? The things that you had to do, but not too much. And essentially, the fact that transformers have become so insanely smart, the encoder, the decoder, this is, by the way, your classic multimodal learning, right? This is a multimodal model because Twin is a visual transformer, right? And you're using a text decoder, like you're feeding it into a decoder to produce text out of it. And in particular, not just plain text, but LaTeX out of it. And it's amazing. And when you do that, the results are just beautiful. I mean, it's just absolutely beautiful. I remember this paper coming out, and the day it came out, I just couldn't believe it. For the longest time, I'd been waiting for somebody to be able to properly reverse engineer a scientific document. And we finally have it. What it means today is that all the knowledge that is locked up in paper journals, in the libraries, all of a sudden now, we can go and convert them back into a digital form.
One question. So the CNN based is not at all good?
Not for this purpose. Well, see, your question, Krishna, is CNN not at all good? So here's the thing. Generally, these days, people apply transformers and they get state-of-the-art results. But here is an interesting thing. Very recently, a paper came out that has turned that whole belief on its head. So what somebody did is they said, okay, if we take a CNN and we make it the same size as this ginormous large language model, so this is the same size transformer as this large language model, how well will that CNN perform? And to everybody's surprise, they found that CNNs do just as well. They have comparable performance to a transformer. So now people are sitting back and say, whoa, we didn't expect that. So something is going to happen. People will shake it up and see what it all means.
Is it similar or is it better?
It's not better, it's comparable. Right? That's a recent paper actually, just a couple of weeks ago it came out. So there's as you can see, this field is moving forward at the speed of light. Right? You have to keep catching up. But generally, the orthodoxy for the last couple of years has been that your go-to approach should use transformers for most of these things. They tend to have better performance. Right? And throw in a CNN, but don't forget to bring in attention head somewhere. Right? That's that. And if you look at the results, guys, you would agree that look at this data locked up in some textbook. Look at the fonts there. This is some old textbook with fonts. Today, we won't use such old fonts because we have more beautiful fonts. When you can go through this whole process, extract a LaTeX interpretation of it, LaTeX equivalent of it, and can compile it to PDF. Now, what is the value of doing that? What's the whole point? Remember that the moment you make it into a LaTeX, now it becomes searchable, right? You can search it, you can drag it, it becomes a part of your entire AI toolkit, right? Everything can be done, whereas these images are much harder to make head and tail out of in a search engine, right? And that is that. That's what and look at this again, the left and the right. How much better and cleaner does the right-hand side look? Font-wise. Like, who would like to read this? I don't know if you guys can see. This looks so much less readable than, for example, this looks much cleaner, right? That's
so in the LLM pipeline, this becomes a pre-processing?
This becomes a pre-processing that you feed into your knowledge corpus. What it essentially, its value is that you have unlocked so much knowledge and made it searchable, made it part of your RAG, given it to LLMs to generate new text based on the knowledge in these things. Right? So years and years of research is not wasted. And at the end of it, you may say, well, once you have Donut, it's a small, like one more step beyond Donut. Donut we did last week. Right. And obviously they are all coming out of Meta, but the impact, the real world impact is huge. Right. So that is that. Right. Look at this. You can give it pages with curlies, turns, twists, and then it still comes out with beautiful results. Right. So that is it, guys. That's the end of the paper reading. Any questions on this? I don't know. How many of you like this fact or find this of great practical use? Do you guys realize that when you guys were doing Tika on your archive PDFs, I was telling you there is a better way.
So we should just straight away go to this, right?
Absolutely. You should have used this. Why do you think I was telling you there's a better way?
You should have told us.
But would you have appreciated this work if I had just told you right away?
I didn't enjoy Tika much.
Yes, but this is
I would have appreciated.
This is a quantum leap beyond that, right? For scientific papers, it's a vast leap beyond the next best thing, right?
So, Asif, like you mentioned, for scientific journals, this is really awesome.
Yeah.
But in a very enterprise level setting, the complexity of the documents that we read is nothing beyond tables, right? Tables and forms. So
that is right. So the moment you see, which is why if you go back and look at the list of papers that I asked you to read. So remember, some of these we haven't covered. If you go back to the beautiful AI, where is that? 1 second. Huh? Let me bring that up for a moment. Well, yeah. So by the way, these slides and these summaries, are you guys finding it useful or do you guys refer to? Okay. So you
is there a project specification for the latest assignment?
Yeah, I'll write it up. I'll write and post it. Thank you. Yeah, I'll do that. Yeah. So guys, we covered TR, OCR, Donut, Nougat. Layout So the question, Haripriya, is that of layout detection. Yeah. And this is again related to that. And table transformer. I believe it was one team, Anuresh, in your team, Shivani and Anil Pandey, they were very particular. How can we extract tabular data? For example, you were looking at what was that SEC filing? 10K, right? The 10K filings have lots of tables, etc. There are special transformers for that. We never got time to cover all those research papers, but the answer is sitting there in these papers, and they are all available now as libraries. We covered TechSnake, but I didn't cover two of the original granddaddy papers of the past. If you get some time, go read it on your own, right? But I'll stop there. But yes, you're right. Right. In enterprise setting, unless you're in a mathematical domain, you don't need it. For me, this was very exciting because that's what I do. I can't write any text without equations and symbols coming in.
But this would still do well in enterprise setting.
Absolutely.
You do have tables as a way to tick up.
Absolutely.
I mean, what's the alternative to this if you didn't want to use it?
Oh, there are very few. I mean, for me, this was a game changer. I liked it very much. This is amazing. So, Satyam, now to your answer, right? Now you know why I was telling you for a couple of months. There is a better way.
I'll try it out because I would like to understand that when I ask questions, how does it actually bring out this content?
Yeah.
See, because I mean, earlier so far, Tika would just give me sentences, right?
Yeah.
And then we would chunk the sentences. Now, whatever this output is going to be, it's going to be text, it's going to be images, it's going to be tables, it's going to be equations. So even my chunker needs to be able to handle something.
Yes.
Like a blob.
Yeah. Yeah, Satyam, think about it this way. You could not have asked this question that, let's take any of these, right? How is theta defined for this particular algorithm? You simply couldn't have asked this question. But now
the point is, as it generates, this is, see, my initial pipeline was Tika with Spacey and chunking. Now this cannot be Tika plus, so Tika plus Spacey gets replaced with this. And then the output is not just sentences, but it's like sentences, images, things. And even the chunker needs to be careful on how it's processing. That is right. So these are the realities, right? So once you see the actual reality and the diversity of text, you realize that you need many, many pipelines to process many different things. All right, guys, any other question, any comments?